all of your JMC is up to date. So do me a favor, check and see where you are JMC-wise. I think that would be a good thing. Again, we've got just a little over 2 weeks to go to get through the trimester, so be staying on top of that. Any late work that's out, guys, don't be procrastinating on that, okay? We don't want to wait right up until the end of the trimester to get stuff in. Numbers-wise, I'd have to look, but I know that we're up over that 80% mark. I think we're right around 83, 84% as a whole class, and I'm really pleased with that. So let's try and make a push to get to 85 by the end of the try as a whole group. Think that's attainable, guys? I think it is. All right, I think it is. So keep doing the good work, all right? You guys are doing great, okay? Guys, 3.5 is titled Solving Polynomial Equations. I was up in Minnesota for the weekend, and yeah, you know how they talk up there? Kind of goofy, aren't they? Anybody ever listen to a real Minnesotan talk? Everything's like, yeah. Oh boy, I started doing that, and I was like, don't do that, don't do that, okay? All right, solving polynomial equations. Here's the deal today. One thing that's not going to go away is everything from 3.4 in terms of factoring. So you might want to have that section out as we progress through this section in terms of factoring. You know, if it's starting to stick in your head and you know what we're doing, you know, if the factoring is becoming easier and easier and easier for you, today's going to be pretty easy. But if not, I would look at this as another opportunity to practice some factoring today. Okay? All right. Volunteer to read our essential question over solving polynomial equations. Who wants that one? I don't have Jaden here today. Someone's going to have to step up to the plate.
Essential question.
Yep.
How can you determine whether a polynomial equation has a repeated solution?
Okay, we'll talk about repeated solutions and what they mean today, but we're also going to talk about how do you solve a polynomial equation. So our goals today, first one is to find solutions of polynomial equations, and you're going to hear me say this a lot. Okay? A lot of times solutions, not all the time, in context do they mean the same thing, but if you hear me say find the solution of a function or a polynomial equation, typically it means find the zeros. Okay? And we'll talk about what that means here in a second. We're going to use what's known as and this is going to be a toughie, all right? We're going to use what's known as the rational root theorem. This will be very new for you guys. Okay? This will be very new, and I'm not going to lie. It can get very long. Okay? The process can become very, very long. All right? And then the last thing we're going to do is talk about using the irrational conjugates theorem. Whoa. Sounds pretty tough. Honestly, it's not that bad. Okay? Let's talk vocabulary first. Those are our 3 goals today. Volunteer to read repeated solutions for me.
A solution that appears more than once.
Okay, let me ask you this. I'm going to ask you to solve this equation right here. If I had an equation like that, where it said x plus 2, that quantity, times the other quantity, x plus 2, is equal to 0 here. This is a plus sign right here. If I said x plus 2 times x plus 2 is equal to 0. Let's see. In order for a product to equal 0, doesn't one of the values have to be 0? In other words, something times something else equals 0. Doesn't one of the 2 things have to be 0? Okay. So kids, my question is this. What would go in right here? What would go in right here to make that 0? In other words, what value plus 2 makes that quantity 0? Negative 2. All right? Or maybe the second one is 0. What would go in here to make this 0, kids? Negative 2. How many times does negative 2 go in to make either quantity 0? It can go in how many times? Twice. And when we say when it goes in there twice, we would say x equals negative 2 occurs 2 times. It's considered a repeated solution, which I'll abbreviate RS. Okay? Because in each one of those quantities, negative 2 makes each part 0. So negative 2 was an answer here, kids. Plug negative 2 in here. What's negative 2 plus 2, kids? 0. What's negative 2 plus 2 here? What's 0 times 0 then? Okay, so for each quantity, x would equal negative 2 there. We call that a repeated solution. All right? Next vocab term is called roots of an equation. Roots of an equation are values where a function crosses what? The x-axis. These are also known as what, kids? Okay, if I had a graph that looked like this in this box, let's just say, here's my coordinate plane. Here's my graph of some function. Maybe it comes through like this, down like so, and back like this. Maybe -6 is where it crosses here. Maybe this is 1, and maybe this is 4. I would say the zeros, or the roots of that function, are what, and what?
Can you slide that over a little bit?
Yeah. Which direction?
That way, yeah.
And that second vocab term, roots of an equation, values where a function crosses what, kids? X-axis. These are also known as the zeros. What are the zeros of that graph, kids? Think of 6, 1, and 4. Okay, so you know that. The zeros are where they're going to cross the x-axis there. Okay. Next term, real numbers. Real numbers are either all positive numbers, all negative numbers, or I should say, and 0 with that. Okay, so we know what real numbers are. Last one's going to be kind of new for us. These are called, whoa, I didn't want to block it out. What's that word, kids? Okay. Conjugates is what they're called. These are going to be binomials. Binomial meaning how many terms? 2 terms. Okay. Binomial meaning 2 terms with opposite operations in here. So if one of my terms was x plus 9, the conjugate of x plus 9 would be not x plus 9, but rather, you want to guess? Not plus 9, but minus 9. Okay, x plus 8 is a conjugate. X plus 9 is a conjugate for x minus 9. 2x plus 6, what's its conjugate? 2x plus 6, what's its conjugate? 2x minus 6. Cat minus dog, what's its conjugate?
Plus dog.
Cat plus dog. Okay. All right. Terms then. We're going to have repeated solution. I think you get that. Roots of an equation, just know roots are where the graph does what again, kids?
Crosses the x-axis.
Where it crosses the x-axis. We're going to have real numbers that we're talking about. Eventually we'll get into the imaginary number system, talk about what's going on there, and then conjugates. Know what that is. Okay. All right, guys. So what are we doing here today? Well, honestly, we're doing the same exact stuff. Okay? Guys, instead of just saying, ooh, let's factor a polynomial. Isn't that what you did all last sections? Take that polynomial and break stuff down and factor out what you could factor out. Isn't that what you ended up doing? Okay, well, here's what we're going to do today. We're going to start looking at solving polynomial equations. Okay? Our polynomials are not just going to be an expression anymore, but rather they're going to become an equation, meaning that these polynomials are now equal to something. Okay? And one note I want to make is this. When you factor stuff, factoring usually works best when your polynomial function, whatever it is, I'm going to call it f of x, it's a good idea to make it equal to 0 before you start working with it. Okay? And we'll look at some examples where the functions aren't equal to 0 to start with, and that'll help us figure out, well, how do I solve it? So here's how you solve this today, kids. All right? It says solve this polynomial equation. In other words, what values of x could I plug in up there to make this equation true? And it says solve by what method, kids? Factoring. Okay. So over here on the left, I have a polynomial function, 5x cubed minus 40x squared plus 80x equal to 0. We need to figure out what values of x are going to work. So guys, as I look at the left side of that equation, how many terms are in that left side of the equation? 3. There's 3 of them, right? Okay. In those 3 terms, can you see a common factor that we could factor out anywhere? Look at the 5 and the 40 and the 80. Can you think of a number we could take from 5 and 40 and 80? What would factor into 5, 40, and 80? Somebody say it loud enough so I can hear it today.
5.
5 would come out of all these. I can take a 5 out. Any terms I can take out? Yell them out if you know.
X.
Can take an x out of each one. I'm taking 5x out of each one of these. Watch what happens. Okay, if I take 5x out of 5x cubed, what's left, kids?
X.
X to the.
Second.
If I take 5x out of negative 40x squared, what's that going to become?
Negative 8x.
Negative 8x. Yep, the 40 divided by 5 is negative 8x. How about 80x divided by 5? Can you think of that?
Plus 16.
Plus 16. Good. We're going to keep this equal to what, kids? Well, it was equal to 0 to begin with, wasn't it? Wasn't it equal to 0 to begin with? So here's how this works, kids. We've pulled out the 5x. Now I need to look at this part and ask myself, well, are there two numbers that add to negative 8 and multiply to positive 16 at all? Where we could factor that second part? Negative 4 and? So you're telling me, Xavier, I should write this as 5x times x minus 4 times x minus 4 and keep this equal to 0. All agree? Okay. Have I factored that completely, kids? Can I break 5x down any further? No. Can I take x minus 4 down any further? Can I take x minus 4 down any further? All right, so here's how we solve this then. Okay, here comes the solving part. In order to solve this, kids, what you're going to do is take your factored completely polynomial. How many different parts are there to this? How many parts did I underline there? How many parts did I just underline? 3 of them. All you're going to do is take those 3 parts and set each one individually equal to 0, and that's going to get you your solution. So here we go. This is how this works. You set 5x equal to 0. I'm going to set x minus 4 equal to 0. And again, I'm going to set x minus 4 equal to 0. Okay? Guys, if I solve the first equation, 5x equals 0, what's your x value? 5 times what would make 0? So x equals 0 is 1 root. One solution. What's going to work here? X minus 4 equals 0. Well, solve this equation.
Oh wait, x minus 4 equals 4?
So x equals 4 is a solution.
Yeah.
What would you have over here again? Would be x equal what?
How does 4 minus 4 equal 6?
That's a 0.
Oh.
Okay. What's my repeated solution in this? 4 is. Okay. Yeah. 4 repeats itself. All right. Now I want to show you something real quickly. What do we think our answers are? 0 and what? And the repeated solution here is?
4.
I'm going to jump into decimals here quickly. You guys don't need to do this. All right, help me out, kids. What was the original function there? 5x to the, was it third?
Yeah.
So I'm going to go 5x to the, where's my function? Let's go 5x to the third. All right, you going to read the rest of me, Sterling?
Negative 40x squared
Minus 40x squared.
plus 80x.
What's going on here? Minus 40x squared, you said? And then plus 80x? Let me show you something real quickly, kids. What were our x values that we just got there? What were our 0? Okay. There's one place where it crosses the x-axis. Here's another one. Now, guys, notice 0 is one x value we got, and then we got 4 again. But notice right here, does this line cross the x-axis at all? What was your repeated solution in that? What was your repeated solution?
4.
So this 4 right here means when it comes down, just touches the x-axis, this 4 kind of gets accounted for 2 different times right here like that. And we'll talk more about that as we progress through the chapter. But Guys, where does this graph cross the x-axis? Well, it looks like at 0 and at, looks like 0 and 4 to me. Okay, so there and there. Okay, and didn't we get 0 and 4 for that? So factoring. Factor it completely, set each part equal to what? Set each part equal to 0 and solve. Okay, that's how you do that. Nothing really different. We're just setting it equal to stuff now and figuring out what the x value is. Okay? All right, questions example 1 at all? All right, let's roll example 2. Okay. It says finding all the zeros of a polynomial function. Okay, we'll sketch the graph with Desmo's help, but guys, again, same thing. Help me factor this. I'm not going to talk, you guys help me.
Got this.
Help me factor that.
Okay, it would be.
Okay, the giveaway should be that when I have a 4th degree function like this and that middle term is showing up as an x squared term, it's kind of like factoring a quadratic. So somebody help me. What's this going to factor into? Who knows?
X to the second minus
So,
9.
okay, this will become x to the second minus 9.
Then the same thing.
Let's just double check here. You guys agree the x squared and the x squared make the x to the 4th out here? You agree the minus 9 and the minus 9 product of that is the 81? So I need to check inside, outside. This is negative 9x squared. This is negative 9x squared. Okay. That's negative 18x squared, so I agree with factoring. Okay. Now, think about x squared minus 9. Could x squared minus 9 be broken further? That there's the difference of perfect squares, isn't it? So couldn't this x squared minus 9 now become the following? X minus 3 times x plus 3? Would you agree with that? And then how about this other x squared minus 9? Doesn't this become x minus 3 times x plus 3 again, kids? Would you agree with that? What are the directions tell you to do? Sketch a graph afterward, but find what first, kids? Find the... Yeah, if it says find the zeros, take your function and set it equal to 0. Okay? Let's just ask ourselves, quickly, kids, what would go in here? What would go in this first quantity right here to make this equal to 0? In other words, what number minus 3 is 0? 3. So 3 is going to be, what would go in here? Negative 3. What goes in here?
3.
What goes in here?
Negative 3.
Gosh, it looks like the solutions are going to be what and what to this, or the zeros are going to be what and what to this. 3 and negative 3. Are there any repeated solutions? 3 repeats itself how many times? We say that would be a double root. Okay, how many times does negative 3 repeat itself? Twice. That would be a repeated root. Okay, so right here, kids, we would say, well, the roots are, or the zeros are, the zeros happen at x equal 3 and x equal negative 3. And then I just want you to sketch a graph of this. Okay, so what you're going to do is you're going to mark positive 3 over here. I'll just put a 3 like this, and you're going to mark negative 3 like this. Okay? Here's what I'm going to tell you guys. What degree was this function to begin with? 4th degree. Okay? Leading coefficient positive or negative? Positive coefficient, positive leading coefficient for an even function. That's going to make like some W there. Okay? Now the fact that you have zeros that are considered repeated solutions, this is kind of what it's going to look like. It's going to come down. It's going to touch right there. It's not going to cross it. Take off this way. Come back. Go through like so. Okay? I don't want you to get too excited about this. Okay? What I'm concerned about right now, kids, is where are your zeros. So what I want to see on your sketch is -3 and +3. And I want you to make the connection that, ooh, -3 and +3 are the values I would plug back in here to make this equal to 0. All right? Sketching the graph, what do I want you to use as a tool to help you get the sketch down? I want you to use decimals. So I'm just going to jump in here quickly, and I'm going to be very honest about this. Again, what I'm after really, guys, today is you make the general shape like this. Make sure you have your zeros labeled. Let me get into this quickly. All right, what was it? X to the 4th minus 18x squared plus 81. Was that right, guys? Does that sound right? X to the 4th minus 18x squared. Was it plus 80?
1. Plus
81. Okay, now I'll just zoom out a little bit. But guys, does it look like it kind of comes down, touches at -3 right here, touches at -3, takes back off up here somewhere in the middle, comes back down, touches at what? +3. Okay, so really, I know my sketch isn't perfect draft, but we get the idea that, ooh, it comes down here, and touches at 3 and -3 there. Okay. Now the reason it just touches at -3 and +3 is because these are what's considered double roots. 3 happens twice. So again, we'll talk more length about that here as we get into some of the harder concepts with this. Okay. All right, let's talk about how factoring works here. This will be something that I'm going to be very honest with you. You're going to be like, oh, I don't know if I like that person. I'm going to be like, yeah, I don't blame you. It's kind of long, tedious, hard, difficult work right here. Okay, there's a core concept up here that says the following. If I have a polynomial function of the form a of n, a is some coefficient out here, x to the n all the way down to some constant, has what kind of coefficients, kids? Integer coefficients, counting numbers, 5, 7, 9, -2, -14, whole numbers, positive, negatively. It says then every rational solution of the polynomial function equals 0 has the following form. It says p divided by what, kids? Q, factor of constant term a of 0 divided by factor of leading coefficient a of n. Okay, here's what I want to tell you. All right, I'm not going to worry about this notation in terms of a. Here's what I really want you to understand. Down here it says find all real solutions of x to the 3rd plus x squared minus 14x minus 24 equals what here, kids? Okay, is equaling 0 a good thing for us like we've talked about so far, or is that a bad thing? That's a good thing, okay? Now as I look at this right here, I'm like, you know what? I'm just going to do this up on the board here quickly. We've talked about in the past when you factor things that you can factor things when you have 4 terms by possibly splitting stuff. Help me split this. What would come out of here and here? That's what you get here is x squared times x plus 1. You guys agree I could take -2 out of both of these? Guys, the parts that are in parentheses this time, the x plus 1, the 7x plus 12, are they exactly the same thing? They're not. Okay, so this is where we start running into troubles, all right? This is where we start running into troubles. We're like, ooh, I can't split that factor because these two quantities, x plus 1 and 7x plus 12, are not the same. So I can't do that. So here's what we start talking about, kids. We start talking about, okay, if I could just find one factor to start with, that would be good. If I can find one factor to start with, that would be good. All right? Now, this rational root theorem is a big concept in mathematics, especially the mathematics you're involved with. All right? Here's what we're going to end up doing. And here's what I always tell kids. What's your constant factor in this? In other words, what number doesn't have an x down here in the polynomial? Negative 24, okay? Just write down that p is equal to plus or minus 24, okay? And then your q value, kids. Your q value is going to be the value that's the leading coefficient part. Okay, what's the degree of this function? What degree is this function that we're trying to solve for?
Third.
It's a third degree. So what's the leading coefficient of that degree 3? 1. Okay, here's what we do. Okay? I'm going to write a 1 down here. All right? I'm going to make a note up here. Here's what you're kind of looking for. Okay? Your constant value that's in the polynomial is going to be like your p value. All right? So instead of having minus 24 out there, suppose I had plus 56. What would the p value be for what we're about to do? Well, it would be a constant 56. What if there was no constant out here? What if this minus 24 wasn't even here? Then what would be your constant value, kids? 0. Okay? And then I'm going to tell you a part here. Look at your degree of your function. I'm going to write it this way. Okay? I'm going to write down coefficient of highest degree is your q value. All right? What's the highest degree to that polynomial? Again? What's the highest degree of that polynomial that we're trying to factor and solve for? 3. What's the coefficient for that?
X.
How many x cubed?
Oh.
Just 1, right?
Yeah.
Okay, so that means q is 1. All right. What this says is the following, kids. It's saying that if you have coefficients that are integers like we have up there for our polynomial, this is simply saying that, you know what, one of the possible factors, I'm not saying one of the definite factors, but one of the possible factors come from a possibility of your factors of q, your factors of p, or your factors of p divided by q. So here's what I tell kids to do all the time, and I think that this helps a lot. I like to make a chart for this. I think this helps a lot. Make my chart just like this, and I think you should kind of do the same thing. Don't go all the way across your paper because we're going to need some room to do some synthetic division. Okay, let's start with the 24. Can you guys think of factors for 24? Obviously, the lowest factor you can always start with is what, kids? One. Does 1 go in there? You bet. What's another factor after 1 for 24? What other number would go in this one? 2 goes in there, right? 3 goes in there. Let me make some room up here quickly. Hang on 1 second. Oops, I didn't want to do that. Did you say 6, Xavier? Okay. What's the last one? Now notice what signs did I put in front of all my numbers?
Plus minus.
Yeah, because a factor of positive 4 could also be positive 2, but also what else goes into 4? Well, negative 2 does. Okay. Now how about your Q factors, kids? What's the Q factor? Be plus or minus what? Factors of 1. The only factor of 1 is what? 1 itself, isn't it? So the only factor of Q is plus or minus 1. Now the nice thing about this, and we'll look at an example I think that's more difficult here. I want to check something here real quickly. Oh yes, this next one will be more fun to do, okay? What we need to do here, kids, then is look at all the possible combinations of our p-values divided by all of our q-values. In other words, we need to consider this p-value of 1 divided by, good thing the only factor down here is what? 1, okay? Well, what is 1 divided by 1 still, kids? 1. All right, then you need to check 2 divided by 1, which is still what? Well, 2. Now, I'm not going to write all these down here because if I take all these values p up here and divide them by 1, aren't I going to get the same values that I have right up here again? Every single time I'm going to get the same value, okay? What this is telling me is if there's a factor to this, one of the factors up here is going to become one of these right here, okay? So let's just check, kids. How many factors might we have to check here? How many factors of 24 were there? Weren't there 8 of them? Well, 8 of them could be positive and 8 of them could be, if there's 8 positive possible factors, that means there's also 8 possible negative factors, okay? Which means, what's 8 and 8? We might have to possibly check up to 16 factors to figure this out. Are you kidding me, Parson? So here's what you would start doing, okay? What would be the first factor I would probably check here, kids? 1. See if 1's going to be a factor. Let me check. You do all this synthetically. Don't write this down, all right? What are the coefficients of that polynomial function for synthetic division? Let's see this. It's going to be 1 minus 14 and minus 24, right? All right, kids. Let's check right here. Let's see if 1 is indeed a factor here. Help me do this, kids. Bring down to 1, 1, 2, 2, negative 12. Oh my gosh, is this going to work right off the bat? No. What do I get for a remainder here, kids? And again, you don't need to write this down just yet. Don't write any of the synthetic stuff down. What do I get for a remainder here, guys? 12. So is 1 a factor? No. The answer is no. It's like, ah. All right, so well, if positive 1 didn't work, maybe check negative 1. All right, let's do that. I'm just going to roll on this. You guys trust me? Negative 1 a factor?
No.
Why not? Didn't get a remainder of 0. So now that I've exhausted this right here, plus or minus 1, whoops. I know that positive 1 can't be a factor, so I might come here and say, oh, all right. Okay. Do you want me to keep checking all these, or do you want me to tell you which one's going to work? Let me find the one that's going to work, and then I'll show you how to proceed here, okay? Because the next example, we're going to kind of do the same thing. Whoops, wrong, what? I can't remember which one it is, so let me look this up quickly. It's 3.5 on top of your notes, kids. Yeah? Okay. What example number is this? 3?
Yes.
Okay, I'm going to go this way right here, kids. I'm going to tell you, we're going to get to the plus 2 and the minus 2, okay? I'm going to run through the 2's real quickly. Don't write this synthetically, all right? Tell me what my coefficients are for 2 again, kids. Was it 1, 1, negative 14, and 24? Was that right, guys, on that example? Is that right on that example? Okay, let me run through a 2 and see what happens here. 1, 2, 3, 6, negative 8, negative 16, 8. That didn't work. Let me try negative 2. All right, here's what I want you to do. I think I want you to write negative 2 down synthetically in your notes right here, okay? Now, watch what happens here. When I test the negative 2, and again, this is why synthetic division is so nice. something doesn't seem right here. Is this a positive one or negative one here, guys? 1, 1, negative 14, negative 24. That's not the right one here. Oh, that should be a minus 24 in the end, shouldn't it, guys? Shouldn't it be minus 24? Yeah, this should be minus 24 right here, right? Okay, well, I'll tell you anyway, on the ones that we would have done already, they wouldn't have worked here, but let me just show you here. Where's my work at? That should be a minus 24. So this would have been negative 36 up here. All right, watch right here, kids. That would have been negative 10. Again, didn't work. All right, watch this right here. This 24 is negative right here. So this and this, okay, what happened right here, kids? What remainders are good in our book?
0.
Zeros. Okay, let me show you. Right here, guys, when you write this synthetically down, this would have been one that you found to say works. We know that one of the factors is going to be what value, kids? We know, because the remainder is 0 down here, we know that one of the factors is going to be what? Negative 2 worked, okay? Here's the deal. When negative 2 worked, kids, we talked about synthetic division kind of gives us a quotient down here. This is my remainder. This would have been my constant. This would have been my x1 term. This would have been my x2 term. So since negative 2 is a solution here, kids, we take negative 2 out. This means that we've now gotten this down to x squared minus how many x? This would be 1x squared minus 1x minus how much as a constant? Minus 12. So I'm going to go back to my notes here real quickly. When we started applying all these numbers here, whoops. When we started applying all of these numbers here, we got down into a situation and said, well, we're going to test the negative 2. And the negative 2 tested the 1, 1, negative 14, negative 24. We got a remainder of 0 on that. Okay, that meant that this factored into this part down here factored now into x squared minus 1x minus 12. And we would still equal that to 0. Okay? Now, we would love to find a couple other zeros to this. Guys, can you factor x squared minus 1x minus 12 now? In other words, can you think of two values that add to negative 1 and times the negative 12 at the same time? What are they, Gabriel?
Negative 4 and 3.
So I can write that as a quantity x minus 4 times the quantity x plus 3 now, couldn't I? Yep. So what Gabriel's saying, hey, we know that negative 2 is a solution. Now, after I took negative 2 out as a solution, we're down to a quadratic here where this will factor into, you said x minus 4x plus 3, right, Gabriel? Yeah. Ooh, that's good, because now, and it says x minus 4 times x plus 3 equals 0. Let me blow that up one more time here, okay? Way down at the bottom there. Okay. Well, guys, what I could do is what we were doing with factoring. I could set this x minus 4 equal to what now, guys? Well, 0. What number plus 4 makes 0, kids? Or I'm sorry, what number minus 4 makes 0? 4. What would go in here to make this 0? Negative 3. So we say my solutions to this are negative 2, positive 4, and negative 3. By the way, what degree was my function to start with? So how many solutions are we probably going to have? The degree is telling you how many solutions you're going to have. Now, some of those solutions might be a repeated solution like we talked about already. But from this right here, guys, from this right here, I can get now that x could equal positive 4, x could equal Negative 3 would make that 0. And we already found one synthetically. What was the other solution? Well, x equal negative 2. All right? Negative 2, 4, 3. Let's try this again on the next example. I didn't like having that q value be just 1. I want to show you the effect of p over q here, all right? Show you the effect of p over q. You guys remember quadratic formula? You guys remember the formula for the quadratic formula? You've done it before. Opposite of b plus or minus. We better write that down again, sounds like, right? Okay. Let's run on to the next page, Joe. Let's see if we can't get example 4 done before we get out of here today, all right? Okay, we're going to use this rational root theorem idea again to try and find the zeros of polynomial function, okay? So if I'm trying to find the zeros here, kids, basically what they want you to do is to take this function and set it equal to 0. Guys, what degree is my function up there? What degree is my function? 4th degree, right? Okay. Means there should be how many solutions? How many solutions should there be? 4 solutions. All right, here's how this works. We need to find our values for p and q. Let's make a chart. Chart for p, chart for q, chart for p divided by q. Oh, lordy. You're not going to like this one. I'm just going to come right out and say it. But that's okay. I want you to understand it. I don't care if you like it or not. Understanding is what's critical here. What are your p-values going to be in this? In other words, what's your constant? What constant is out there at the end of that polynomial? 4. So we need to list all of the possible factors of 4. So I'm going to put a p out here above the plus 4. What are the possible factors of 4?
Plus minus 1, plus minus 2, plus minus 4.
Good. We've got to start. What's the q value in this then, kids? See, q is the coefficient for the highest degree. So we need to list all of the factors of 6. So what are those?
Plus minus 1, plus minus 2, plus minus 3, plus minus 6.
Okay, now we also need to consider factors of all p values over q. We need to consider all possible values p divided by q. So let's start here, kids. How about 1 divided by 1? What's that equal? What's 1 divided by 1? But isn't 1 already accounted for in here somewhere? Okay, so let's do the next one. What's 1 divided by the 2? How would you write that in fraction form? Hey, Whit. Need something? Or hanging?
Yeah. I need your opinion.
Can you give me like 3 minutes?
Yeah.
Want to watch rational root theorem with us?
Yeah, do you write that in 1/2? You said fraction form.
Yeah, plus or minus 1/2 then, right? So I'm going to start with the 1 and divide all these out. So I can have plus or minus 1/2 as a possibility. Let's see, 1 over what next, kids? Plus or minus 1/3. I'm going to write that one down because you know what? Don't have that anywhere up there. What would be the next possible fractional factor after 1/3?
Plus or minus.
1/6.
Plus or minus 1/6 might be an option. Okay. Let's look at the next one then. I've got to look at the 2. 2 divided by all the q's. So 2 over 1 is equal to what, kids? The 2 divided by the 1 would still be what?
2.
Isn't 2 already accounted for up there somewhere? So I don't need to write that. How about 2 divided by 2? 1, but isn't 1 accounted for up there somewhere already? So the next possible rational root for this polynomial equation might be 2 divided by what? Let's see, in fraction form, it would simply be 2/3. Is 2/3 accounted for up there anywhere? So I better put what else down here in this p divided by q chart, kids?
Plus minus 2/3.
All right. And then, oh my gosh, we got this 2 over 6. Gosh darn it, I've got to write plus or minus 2 over 6 down, don't I? No?
It reduces to 1/3.
Oh, so you're saying reducing fractions, that's kind of still a good thing? It's still hip? So we can dab with that.
Oh my God.
All right, okay. 2 over 6 would reduce to 1/3. No need writing that down again because we've already accounted for it, isn't it? So we do the same thing with 4 now. How about 4 divided by 1, kids? Accounted for, right? How about 4 divided by 2? Accounted for, right? How about 4 over 3? Is 4 over 3 accounted for, kids? No. So we better add plus or minus 4 over 3 here. And then the last one, 4 over 6. I have to write 4 over 6 down, right, Annika? No. Why don't I have to write 4 over 6 down?
Reduces to plus minus 2 over 3. We already have that.
Annika, if I'm telling people that rational root theorem is this thing where we can find roots to any polynomial function or zeros of any polynomial function, and this rational root theorem thing is something we're going to use to do it, when we run into the fractional parts, would you tell people it's probably a good idea to just put your fractions down as they appear, or maybe think about simplifying those fractions? Definitely want to simplify because there might be some overlap with that, okay? So make sure you're simplifying fractions on this. Now kids, let's just check. How many of these would we have to check? Well, we got plus or minus 1, 2, and 4 we have to check. Let's see, 1 and 2 occur here. Do I need to check those again then?
No.
What whole numbers do we need to check?
3 and 6.
1, 2, 3, 4, and 6, right? And then we're going to have to check every single fraction. So there's a possibility of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But 10 times 1 can be positive, another 10 can be negative. There might be a possibility that you might have to check how many different factors before you find one. 20 of them, okay? You might, Brad, I see your head shaking side to side like that. Lay down and do that. That's a good thing, okay? All right. There's a possibility we're going to have to do this 20 times, okay? Now, do you know these problems are kind of set up that hopefully by the 3rd or 4th time you have it? Here's what I would encourage you guys as you're going through an assignment. I would encourage you guys to get these things set up synthetically and help each other. So like, maybe Xavier says, I'll do the positive ones, you do the negative ones. And then when one of you get one, then we can work from there. Can I tell you which one's going to work right away? Are you guys okay with that? Okay. We'll give you 1.14 minutes here, all right, and I'll be right with you. Can I tell you which one's going to work first?
Wait, so
We by no means are going to finish this.
I have a question.
Yep.
So you said, wait, can you go up a little bit?
Yep.
So you said when 1 over 1 was already accounted for, how? There's no...
Well, but what's 1 divided by 1 make?
1.
One shows up in the P row, and it also shows up in the Q row, so there's really no sense in, I mean, you can write them all down,
Okay.
and if you want to write them all down, Annika, I'm okay for that. I guess I'm the kind of guy who says, well, 1 divided by 1 is already in one of the rows, so I don't really need to write that down again. Does that make sense?
Yeah.
Okay. I'm going to tell you which one here works first, and I've got to double check this. Guys, is it okay if I start out? It turns out 1/2 works in this. So help me with this synthetically. 1/2 is going to become a factor here. So I'm going to put 1/2 up in the box. Guys, what would my integer coefficients be for the polynomial? Somebody have that in front of them right now?
Be 6, -11, -16, 2, and 4.
And we didn't skip any degrees there? No, there should be 5 terms. Okay, so you guys help me with the math because it's Monday morning and I drove back from Minneapolis and I'm tired. What's next, kids? 1/2 of 6. 3, add this up is -8. What's 1/2 of -8?
-4.
-4 in this is -20. What's 1/2 of -20?
-10. -8.
-10, this would be -8. 1/2 of -8 is?
-4.
Gosh, what do you notice about the remainder here again, guys? 0. I would say get to that part right there. Make sure you've got this down synthetically. We've just shown that 1/2 is a root. I'm going to kind of help you with the roots because I really don't want you spending time. I know you know how to do synthetic division, okay? What I want to make sure is I'm not deflating you by making you do 20 of these. You think, gosh, I can't find a root. I'm on 17th one yet, Carson, and I still haven't found a root. Okay. So if you guys can do me a favor, you show me the P chart, the Q chart, and P over Q chart. I will kind of, you get those. I'll come up and say, try this one first. Sound good? All right. I'll shut my office.
Yes, I love
I will. I'll send the online out. Won't be doing until Wednesday, but I'll send that out here in a little bit. So if you need to want to get in there and start looking at that, feel free to do that. Okay. Hey, how many of you guys are? Keith, you're coming Wednesday to finish up?
Yeah.
Okay. Very good.